Hey everyone, today I'm going to teach you how to build a data pipeline to ingest real-time stock price data from a WebSocket and into two different persistent stores in AWS, S3 and OpenSearch. And then we're going to make some super simple graphs in Quicksight and OpenSearch dashboards just to kind of prove that the data is getting there. So from left to right, the entire architecture, we're going to make a WebSocket connection to a data provider on an Ec2. We're going to send that data from the Ec2 into a Kinesis data stream using some Python code, and that data stream is going to have two Firehose consumers that is going to store the data into S3 and OpenSearch. One Firehose will store it into S3, and then we'll graph it and query it with Quicksight and Athena. And then another Firehose will store it into OpenSearch, an OpenSearch domain, which is another name for a cluster. And then we're going to look at a super simple graph on OpenSearch dashboards just to confirm that the data is there. One of the fire hoses, this is the more complicated fire hose because it also comes with a Lambda transformation that we're going to do. We're going to add some dynamic partitioning to the data so that it's partitioned in S3. Okay, so we're going to do all that, and let's get started. The first step is to create the Kinesis data stream that we're going to send our data into, and that part's really easy because we don't have to worry about IAM. So just click, if you've never created a Kinesis data stream in that region before, you'll see that screen that I was just on. Just click Create Data Stream, enter a name, Stock Prices Stream. I'm going to choose Provision because I want to pay the least amount of money possible, so I'm going to provision a single shard. You pay per shard hour, and you can't have less than one shard. So this is literally the least you can pay for this thing, is to provision just one shard. And shard just controls your throughput, essentially. It's horizontal scaling. And then keep all the other defaults because we don't want to overcomplicate it if we don't have to. While the Kinesis data stream is provisioning, you can go over and start provisioning your EC2 that you're going to need to create the socket connection. So I'm going to call it stock socket EC2. I'm going to use the default operating system and architecture, stay on the micro instance since it's on the free tier and I want to save money. I don't have a key pair in this region yet, so I'm going to create a new key pair. I'll call it stock pipeline key. Keep it in RSA. When it creates it, it downloads it to your computer, and I'm already in the folder that it downloaded to, so I'm going to just change the permissions really quick so that we can use it for SSHing into the box here in a moment. And I'm going to return to this EC2 wizard. I'm going to put the EC2 in a security group that locks it down just to my IP, so it's not like open to the public internet. And then I'm going to expand this advanced details tab because we need to create an IAM role for the EC2 to use to put data into Kinesis. And so I'm creating a new IAM role. I'm creating it for an EC2, and I'm going to give it privileges to Kinesis. So I'm just going to go ahead and give it Amazon Kinesis full access. And it wants a role name, and I came up with one earlier, so I'm going to paste that there, and we're going to take, I made it earlier, so how about that? Okay, there's that. So this is the role that I just attached, or I'm about to attach to the EC2, and on that role I'm going to add an inline policy to allow it. And I'm going to copy that over. Let me show you what that looks like. So we're going to move to the JSON view and delete it. And so this inline policy is going to allow the EC2 to read Alpaca params from the parameter store. So some of those params are the Alpaca key or the Alpaca API key and the Alpaca secret key. But I've got a couple other things that I'm just calling Alpaca params that that EC2 is also going to read. So it needs permission to read any parameter that starts with Alpaca. Okay, so I'm adding that inline policy. And this also needs a policy name, which I came up with earlier. This Okay, we created the policy, it's added, so now our EC2 has Kinesis full access and that inline policy that allows it to read parameters from SSM, or the parameter store. Okay, so I'm returning back to the wizard now, and I'm going to refresh the roles in here, and then I'm going to pick that V2 that I was just doing. Okay, and then the rest of this I can keep as is. So we'll wait for that to provision. While you're waiting for your EC2 to provision, we can go over to the parameter store, which is part of the Systems Manager service. That's where the SSM abbreviation comes from. And we're going to create 4 parameters that start with Alpaca, because remember, we gave the EC2 an inline policy that allows it to get parameters from the parameter store, but only if they start with the word Alpaca. Okay, so this is an API key, so I'm going to go ahead and make it a secure string so that it's stored in an encrypted state, and I'll just use the default key to encrypt it. And that's the value. I'm going to change these after this tutorial, of course. I'll create the Alpaca secret key. That's also a secure string. I'm going to paste in the value here, create that parameter. I've also got 2 other parameters that we're going to create. So one of them is the Alpaca stream name, and that can just be a normal string. It doesn't need to be encrypted. And if you remember, so this is the Kinesis data stream that we created earlier. So we called it stock prices stream. And then the other parameter that I've made that the Python code will work with is the symbols to watch. So this is which stocks do I want to pull prices for. And I'll store it as a string list, but I will say that you still have to split this into an array in the code, so it doesn't get you a whole lot. You could either store it as a string or a string list. It really doesn't matter a whole lot. Okay, so these are our 4 parameters, and they all start with Alpaca, so the EC2 will have access to them. So I'll go back over to EC2. We have 1 running instance. So I'm going to pop in here and copy the public IP address. And you can see that I did chmod 600 on the PIM file already, so now we should be able to use it in this SSH command to connect to the instance. Just type yes here. Okay, so now we're connected to our EC2, and I'm going to just run a few things. This will a yum update, so we update all the packages, and then I'm going to install Python pip. They come with Python, but they don't come with pip. And then I'm going to use pip to install Alpaca py and Bodo 3. Because both of these packages are going to be used by the Python code that we're about to create. We're going to create that Python code in the Vim editor, so if you haven't used Vim before, it might be a little bit foreign to you, but it's pretty easy at least to copy and paste stuff into there, which is what I'll be doing. I'll copy and paste it, but then I'll explain the code. Okay, so I'm going to call it runsocket.py. And so this created the file. Now, in order to enter edit mode, I hit I, and you can see it says insert down here. So now I can paste. Oops, pasted the wrong thing. I need to copy my code. Okay, so this just imports some libraries that we're going to use. This defines the region. This creates the SSM client. So this is the client, the Systems Manager client. This is the client that we'll use to pull all the parameters in. And here's where I pull all the parameters. Notice that the 2 API keys have this extra parameter that we're sending into the get parameter function with decryption set to true. So that'll decrypt those secure strings as well. This is just some debug purposes. This sets up the WebSocket stream. We don't run it until we get down here. So if we create the WebSocket stream object, and then we subscribe to quotes through it, and then we run the stream. which will actually set up the connection at this point. And every time we receive a message through that stream, it will call this quote data handler function because we passed it in right there when we subscribed. And every time that function is invoked, we will put a record into our Kinesis data stream. So you can see that we define that Kinesis client here using the same Boto3 type command that we use to set up the SSM client. We can set up a Kinesis client, and then we can just call put record on the Kinesis data stream. We pass in the stream name, the data in a JSON stringified form, and then we pass in this partition key, and the partition key is used to determine which shard your data goes to. Now in our case we only have one shard, so it really doesn't matter, but I think that the partition key might still be required. It's good practice to put it in anyway. Okay, and then these are just a couple debug statements in there. So every time we receive something from the stream, we're going to pull off the bid price, the ask price, the symbol that the quote is for, and we're going to pull off the timestamp, and I'm converting that to epoch time in microseconds so that we don't lose our precision, but I do want it to be an integer instead of a float. Okay. So, and to get out of this, I pressed escape and then colon and WQ down here and then exclamation mark and hit enter. Okay, so that should be all set up. And let me check my notes here. We've created the parameters and okay, so we should be able to run this script now. Hopefully it'll work. It did not. We're getting an access denied from the parameter store. Okay, so it took me a minute to figure this out, but if you read this error message that it's getting, it's saying access denied from getting the parameters from the parameter store, and it says you're not authorized to perform this action get parameter, which is the action that we specifically did authorize in our inline policy, but on this resource. And if you look at the resource, it's talking about US East 2, and right now we're in US West 1. So that's because I did this before and I did it in East 2, so let's change that to West 1. Okay. All right, and now let's run it again. And boom. So we're getting data back from Kinesis. These are, sorry about that. These are all responses from Kinesis, and I'm going to stop this so we can look at one of them. But this gives the shard ID, the sequence number, maybe most importantly, the request ID, and it's saying retry attempt 0, so it looks like everything's succeeding from what it looks like here. And we can see also this is what the data looks like. So we got this epoch time timestamp, the symbol, and the bid and ask prices. So for our first checkpoint, what I want to do is go back over to our Kinesis data stream, and I want to go into data viewer, and we're going to pick our only shard ID with all zeros, which is, if you remember, the same shard ID that's showing up right there. And we're just going to take the trim horizon here. No records found. Latest, no records found. Let's try 2023 12, and it's 29th. We're just going to do all zeros here. So it took me a minute to figure this one out as well, but for whatever reason, I had to get more specific with the start time and put it at 10 a.m. and then I see that the data is there. But you know, if I change this to all zeros again just a second ago, it wouldn't. Yeah, it's still not giving me any records. So I'm really not sure why that is happening, but the data is getting in here. So we're all learning something today. Checkpoint passed. Next, we're going to create a few S3 buckets. the first one is just going to be to hold the data that is going to come from the Kinesis data stream through a fire hose into S3. So this will be that bucket. We're creating it in West 1 region, and we're just going to keep all the other defaults. So we're just giving it a name, and then we're also going to create another bucket, and I'm just going to call this my junk bucket. And this is going to contain things like the Athena results. When we run queries in Athena, it requires a place in S3 to put data, and Firehose, in some circumstances, asks for a place to put things. So we're just going to keep that there as a place to put things if we need to. Okay, so now we're going to go to Firehose and hook up the Firehose to the Kinesis data stream and feed our data from our Kinesis data stream into S3. And so we pick the source, which is a data stream, and the destination, which is S3, and that kind of controls how this form looks. Now, another thing that this does is it automatically gives Firehose the permissions it needs here. So one nice thing about Firehose is you really don't have to mess around with IAM unless you have a very specific thing you're doing. It'll automatically give the Firehose access to Kinesis data streams in S3. Okay, so here we want to browse for our stream, pick our stream. We're going to give it a name, which I came up with earlier. We're going to call it that. So this is a Kinesis to S3 Firehose for stock prices. Okay, and we are going to turn on data transformation. We're going to create a Lambda here in a moment. And another thing that we're going to turn on is dynamic partitioning. And the reason I turned both those on before creating the Lambda function is the Lambda function is going to do both of these things. So the Lambda function can transform your data, and it can help you configure your dynamic partitioning. So here it wants a bucket for the destination. So this is not the junk bucket. This is the real bucket that we just created, US West. Okie doke. So, and we also need to enable multi-record deaggregation. These are JSON records that we're feeding through this pipeline, and we want new line delimiters. So let me explain a little bit of this. It just needs to deaggregate these records because it's sending them in batches. The new line delimiter is putting a new line after each of your records, and you would think that it would do that automatically, but it does not. So if you don't turn on dynamic partitioning and you don't use a data transformation, then by default, Firehose just throws all the records into the S3 file without a new line delimiter, and then when you try to read it from Athena, you end up only getting like the first record from each file. I experienced that my first time. I think it's a little bit weird the way that works, but essentially you either need to do a data transformation and like manually add the new line at the end, or you need to enable dynamic partitioning, and that allows you to enable this option right here where it'll add that new line for you. Okay, and then down here, so I'm going to just paste something in and then I'm going to explain it. Okay, so what this is doing is it's saying, okay, whatever that Lambda transformation that we are about to create up here, whatever it sends back as the year to partition by, I'm going to use that for this value here. So it's going to put things in the folder structure year/month/hour, and you could do /minute. You could do whatever you wanted, because I'm going to choose the partition keys to use as the values here in my Lambda function. You can also, and it talks about that here, you can also do partition key from query, where you're kind of configuring what the partition keys are in this form here, but I prefer to do it in the Lambda because it's a little more transparent what's going on there. Okay, and I'm just gonna say send stuff to error slash prefix if it errors out, and that'll end up in the same bucket, so we'll be able to see if any errors occur. And I am going to go ahead while I'm here and change the buffer to 60 seconds here. You probably want to keep it at 5 minutes if you're doing this for real, but I just don't want to wait that long. So what this is doing is it's saying every 60 seconds I'm going to take the records from the Kinesis data stream and dump them into the S3 bucket. So you don't have to wait 5 minutes to see your first records. We'll only have to wait a minute here. Okay, and all that looks fine. We can keep the retry duration at 5 minutes. We've already gone through all of these. We don't need to turn on decompression or record conversion. Okay, so here's where we're going to create a function. So I'm going to choose this general firehose blueprint, and in reality, it just takes you to this page where I choose author from scratch, so I'm not even really using a blueprint, so I don't really know why it said that, but let me grab this name that I decided to call it. We're going to be doing this in Python, so we need to change the runtime environment, and then we can keep all the other stuff. And then I am going to paste in some code as per usual, and I can explain it. Okay, so let's get rid of this and paste that in. Got some kind of debug statements that I had there earlier, but basically this takes in the records that Firehose sends, and it'll be multiple records because Firehose is sending them every 60 seconds to this Lambda function, and it's saying, hey, take all these records, do what you will to transform the data. And also, since we configured dynamic partitioning to use the partition keys that are coming from Lambda, this Lambda also needs to define the partition keys to use. And we pass it back in this metadata here. So I say, okay, partition keys I want to use are called year, month, day, hour, and these need to match what we put in the Firehose settings. So if I cancel out of this for a moment, these need to match these names right here. So remember that. And then, so here I'm just pulling out that timestamp that we had. I'm dividing by 1,000,000 because I had it in microseconds, and I just want to transform it to seconds here, and then I want to pull out the year and the month and the day and the hour from that timestamp. Now, by default, I'll also mention Firehose will create these same partitions for you by default. You really don't have to do this, but again, if you don't have the Lambda transformation, you're still going to have that new line issue, and the timestamps it's pulling out are not the timestamps off of your data. They're off of when it received the data, but it's not actually parsing obviously the timestamp that came from Alpaca as I'm doing here. This is parsing the year and the month and the day and the hour from the timestamp from Alpaca. So that might, be a minor thing because it's running every minute and all that, but it's something to think about, that this is a more precise way to do it because it actually matches the event timestamp every time. Okay. So, all the rest of this is pretty self-explanatory. It comes in like base 64 encoded, so you have to decode it, and then you got to transform it into an object here in order to use it in the rest of the Python code. And then it wants the records in this format, so with the record ID and data, and then this important metadata here. And then we just return that whole batch of records to Firehose, and Firehose will decide what to do with it. So that looks good. We'll deploy it. Okay, and now that we've created the Lambda function, we can come right back to our Firehose that we're configuring here, and we can browse, and it is not showing up, but if we click refresh here, there it is. So this is the Lambda we just created. We want the latest version of it. It's warning me here that the timeout is only 3 seconds, and it just wants the timeout to be, as long as your buffer interval is here. So let's go to configuration here, and there's the timeout right here. So let's edit that. to, I like to give it a few extra seconds just to make sure. Okay, and then that, if we, let's just browse and click this again, maybe it'll go away. It did not go away, but we've changed it, so it should be fine. And we've already configured all this other stuff, so we can just click create delivery stream. So this creates the fire hose that takes data every 60 seconds from the Kinesis data stream and puts it into S3. And it uses dynamic partitioning, so it'll be in folders in S3 by year, day, or year, month, day, hour. And that year, month, day, hour is based off of the epoch time that we got from Alpaca using dynamic partitioning. Okay, so at this point, let's run our socket again, because I don't believe that it will retroactively pull records that already exist in Kinesis, so we're going to have to actively put some new records into the Kinesis data stream, and then this new fire hose will start picking up from there. It will not pick up the old, because Kinesis data stream does retain the records in it, and it does have like replay capabilities, but the Kinesis fire hose by default will not pick up the old records and send them to S3. Okay, so this is our stock price bucket, and there's nothing in there yet, so we'll just wait until there's some data in there. Okay, I refreshed the page, and now I see a year equals 2023, month equals 12, day equals 20. This is the dynamic partitioning that we set up using that Lambda function and the configuration of the fire hose. And we see that we've got some records in, some files in here. It's going to put a new file in every 60 seconds. So every one of those batches is a separate file. And they say, you know, you want your files to be quite a bit bigger than this. These files are way too small for doing it efficiently. People say you want like 128 megabytes or something on that level. So these are way smaller because there is some overhead to opening and closing the files and such. So things like Athena and any querying that you do off of this data is going to be more efficient if the files are a little bit bigger than this. This file is weirdly larger than the other, so I might have been wrong about it not processing the old data. Not sure about that, so let's take a look at the data real quick just to make sure that the data looks okay. Data looks exactly like we expect. It's got new lines in between each of the records, and that's the type of data that we're getting. We see various symbols in there, so we're good. Okay, so now what I want to do is go to Glue, and what we're going to do in Glue is run a crawler. The crawler runs over our S3 bucket, the data in the S3 bucket, and figures out the schema and basically automatically creates like a database and a table, a quote-unquote table schema for that data that exists in S3. So it essentially kind of creates a virtual database over our data that's in S3. So if we go to Data Catalog and then Crawlers, let's create a new crawler. And I think on this main screen, yeah, it says Setup Roles and Users. So I'm not entirely sure if this is necessary because I've never not done it, but I will choose my user to have Glue privileges, and I'll grant full, I'm just going to take the defaults on this. So granting full access to S3, and then read-only is fine because the Glue crawler is not writing any data into S3. That's the fire hose that needs to write the data. The Glue crawler and querying it is just reading it. So read-only should be fine. Okay, and all of this is fine. We'll just take all the recommended defaults here. Okay, now we're going to go create our crawler. So that was just kind of giving Glue itself permissions, and now I'm going to say, let's see, I think I had a name for this. We'll just call it Stock Prices Glue Crawler. Okay, and yeah, the table does not exist yet, so this thing needs to make the table. And so now we add the data source. The data source is in S3. We don't need any fancy network connections here. We just need to browse S3 and find the right bucket, which is the demo stock price bucket. And for some reason it shows that in red, but then you click away from it and it's not in red anymore. We need it to crawl all the subfolders because we have that dynamic partitioning. So this is all good. We can create this crawler. We need to attach an IAM role to it, but we can just attach the same AWS managed glue service role as glue that glue itself uses. So it doesn't need any extra privileges other than the normal default AWS managed glue service role. Target database, so we need to create a database, and that is really just picking a name for it. So we'll just call it stock prices and create the database, and then we can go back to the page we were just on, refresh this, we see stock prices in there. We don't need to fill any of that out. We can keep the frequency on demand, so these glue crawlers, ideally, so we use dynamic partitioning, and we partitioned it down to the hour, right? So one weird thing about glue is that it will not automatically sense the new partitions that are created. The crawler has to run again. And I can also show you in Athena here in a bit another command that will also add the new partitions to it. But what that effectively means is that when you're querying your data, the glue will only know about the partitions since the crawler last ran. So your new data is not going to be available to you in Athena or other things. If you're accessing it via the glue data catalog, you can only access the partitions that the glue crawler knows about. So since the partitions are by hour, I would normally run this probably hourly, and I'd have to figure out which minute of the hour is best, but I would want to run it hourly in order to update the partitions continuously so that when I do query it in Athena, I am able to access the new partitions without having to go in and rerun the crawler first. So that's just a little point. Now I'll show you where. So we'll create this crawler and we'll run the crawler, and we'll come back in a minute once it's done, and I'll show you the partitions that it has found. Okay, so the crawler says it's completed, so let's see if it created a table. So over here in the data catalog, it should have added it. We already added the database, and it should have added one table to that database. And here's our table. So we can click on it, and here's the schema that it found. We see our fields. So, I just called these fields like one-letter fields because it's getting a lot of data in there, and I just wanted to kind of limit the size of the data going into the Kinesis data stream as much as possible. So this is the timestamp, that's the symbol, this is the bid price, this is the ask price, and then it also found out that, hey, your data is partitioned by these fields, and it correctly named them. And the reason it was able to correctly name them is because in S3, the partitions are called like year equals 2023, month equals, and that's why we did that year equals, month equals, day equals, so that the glue crawler would just kind of automatically know what to name the partitions. Otherwise, it would name them like partition 0, partition 1, etc. And you can see it even figures out the data type of stuff pretty accurately. So that was successful, and then we'll see the partitions, and it sees one partition so far. And so like I was saying, if I waited 5 hours and came in here and looked at the partitions, it would still say just the one partition. And when I queried in Athena, I would only be querying data from this partition until I rerun the crawler or execute a command in Athena, which I'll show you in a moment. But if I do either of those things, either rerun the crawler or execute the command in Athena, the partitions will be updated at that point, and then you can query that new data in Athena, etc. So just want to reiterate that because that kind of confused me at first, because although we're using dynamic partitioning, the recognition of the partitions is not dynamic whatsoever. So you really need to rerun the crawler in order for it to recognize those partitions. Okay, so we can go on over to Athena, and we should be able to query our data. So this is our table, and we can just select, we can select from the table. So I just clicked on these little dots and selected preview table. It's telling me that I don't have an output location set, so I'm gonna come in here and just set an output location. That's what I was mentioning earlier, that we needed this junk bucket. So that should be good. Oops. Okay, so now if I run this, it should work. Boom. So that's all our data, and it's got all the fields that it had defined in the data catalog there for this table. Okay, the command that I was talking about, I'm actually going to show you later, but just so that you see it and kind of know it. If I run this, it's going to update the partitions in Glue. It does not rerun the crawler, I don't think, because it happens way faster than rerunning the crawler. So it's like a faster way to update the partitions if you're just trying to do it on the fly. Like if you're already in Athena and you're like, oh, I'm not seeing the latest data because the crawler hadn't rerun, you can just rerun this and it'll update the partitions. I'm not quite sure what else this command does, but I know it does do that. So you can just use that. I'm not going to run it right now. Well, I mean, I can run it, but here, let me run that. It's not going to find any new partitions though, because the hour hasn't rolled over yet. So yeah, it just says it's completed. But normally, if it does find new partitions, it'll print them out down here for you. So now that our data is all in S3 and we're able to query it from Athena, and we've generated the Glue data catalog table that describes our data and makes it queryable from Athena. So we know everything's set up. Now we can go to Quicksight and try to graph the data. If it's the first time going to Quicksight, you won't see this screen because it's kind of like an add-on service for AWS. It's not like the other AWS services, so you'll kind of have to subscribe and like make a separate account for it. So if you're not seeing this screen, it's probably because you're not signed up yet, but this is where it takes me. And one thing I wanted to show you, so first you start off by trying to create a data set. And if you try to directly query from S3, it's going to ask you to upload a manifest file, which basically kind of describes the files in there that you want to pull from. But we want to just essentially Glue data catalog, the Glue crawler already did that work for us. It knows about the partitions that need to be queried, about the structure of the data and everything. So we want to use that. So on here, there's not really a Glue option that I see. So the closest thing is Athena, because Athena ends up using the Glue catalog. Now you'll see that I'm getting an error message, and I specifically set this up to get an error message because I want to give myself access first. Another thing I will mention is I'm doing this in a different region than we just did everything. And the reason is because we just went through everything, and I popped into Quicksight to show you how to graph it, and they don't have the region available that I just did all of that in. So we just did it in US West in California, not Oregon. So I wasn't able to access any of the data that we just put in that S3. And so instead of replicating the S3 bucket to a different region or something like that, and then running the Glue crawler, etc., I'm going to use an old one that I did. I still have a little bit of data in there, so it might not look pretty because it's not a whole lot of data, but there's enough to go off of. But right now I don't have access, so I'm going to show you how to give access to Quicksight. So you click Manage Quicksight there, and then you go to Security and Permissions and click Manage here. And I'm going to give it access to S3, and I want to give it access to, this is the bucket in the original region. This is the bucket that we were just working with, but it will not be able to access that because it's in a region that I suppose is not supported by Quicksight. So we're going to use this one, which holds the same type of data. Okay, and we'll also give it access to Athena. Okay, what is it saying? Select the buckets. Okay, so we're gonna select the same bucket there. That seems fine. Alrighty. So hopefully that worked. Let's go back to the main screen here, click on datasets, new dataset, Athena. That's looking better than it did before. So this is just giving the data source a name. Stay in the primary work group there. Data catalog. And this stock price database is what I named it to begin with. If we were doing it in the same region, it would have just been named stock prices like we named it before. And this is the table that it created in the glued data catalog. And so you can import it to Spice for quicker analytics, but we're just going to directly query it from the S3 data. We could do this, but this directly queries it from S3, more like Athena works. And also, one advantage of this is that it will update with new data as it comes in, as long as that new data is still within a partition that it knows about. As I've said many times now, then when it creates a new partition, it won't know about any of that data in the new partition. But if you, say, just ran the crawler after a new partition was created, all of the data that is then added to that partition, you'll be able to see it update. If you keep refreshing the screen on whatever graph we do, you'd be able to see that data, that new data keeps coming in until that partition rolls over to the next partition, and then you would stop getting new data because it won't get any of the data from the new partition. So hopefully that makes sense. So we'll click visualize. We'll just keep the defaults, and I'm going to make a line graph. And so what I want to do, so this T, let's switch back. Wait, let's get out of here, and I want to choose the type of chart to be a table just for a moment. So I just want to, let's add that to the table. It's querying, it's saying no data, so that's not great. I'm just dragging stuff over because I'm hoping to see some data here. And one reason maybe it doesn't have any data is because the data crawler has not run in that region. So let me switch to glue. And I need to go back to this region because now we're working in the old region. Unfortunately, sorry, I didn't realize that Quicksight did not support all of the regions. Okay, so we'll go back to this table. It knows about these partitions. Let's see what kind of partitions we actually have in the S3 bucket. So this is the S3 bucket we're dealing with right now. It does appear to have some data in here, but it's got day 28 data, and this is all from day 27. So it does not, oh, well, actually, yeah, all of these were from day 27. So that's the reason we're not seeing any data in the Quicksight right now, is because it doesn't know about the new partition. So what do? We go to Athena. Let's go back to Athena in this window. We're in the correct region there. Okay, so I just want to run this command, and we'll actually get to see it add some partitions, or one partition. So partitions missing from file system. So, okay, yeah, it's complaining that all of these partitions that it used to know about don't exist anymore. It didn't actually tell us the partition that it added, but let's see back here if it's updated these partitions. And it has not. So what I'm going to do is completely delete the table. And I'm going to rerun this crawler. And that is going to recreate the table, hopefully with the correct partitions in it, and then I will be able to query the data in Quicksight. Okay, so the crawler finished, so the table should be created, and you might have to refresh this screen. I actually already traveled to this screen and refreshed it, so that's why it's popping up, but I did have to refresh it the first time. But if we click on this table that was just created, so this is the one I just deleted and then recreated, because for some reason running the MSCK repair table did not work, and instead of rerunning the crawler, which would probably delete the old partitions from old data that I deleted out of the bucket, I just went ahead and deleted the table. Since I'm rerunning the crawler anyway, I just might as well just wipe out all the old stuff with partitions that don't exist anymore and create a new table with a partition that actually does exist. So now we got it, and it should be queryable from Quicksight. So let's go back to Quicksight here. I'm just going to go back to this screen, click on this data set, and just delete it so that everything gets updated correctly. Okay, new data set, Athena. We'll call it the same thing. Connecting. All right, so now we'll take that. We'll directly query our data just like we did before. Take that. Okay, so now let's see if anything's in this table now. There we go. Okay, so now we got data. So these are timestamps, so it's adding commas there, but I just wanted to make sure that the data was in there. We can see that T column, that's our epoch time in microseconds. So I'm going to create a calculated field here. I'll call it parsed timestamp. And what I'm going to do first, I want to not cast it to an int, but take floor of the T field, so that's that big integer, and I'm going to divide it by 1,000 and then 3 more zeros. So divide it by 1,000,000 and take the floor of it, which casts it to an integer, just kind of truncates off the decimal portion, because this epoch date function requires that we pass in an integer. It'll fail if you try to pass in an integer, or it'll fail if you try to pass in a double or something. So first we got to truncate off the decimal portion of that, and divide it by 1,000,000 to put it back into seconds, and then we can use this epoch date, which will convert an epoch time integer in seconds into an actual date. Okay, so we're saving that. Let's throw that on this table just to see what that looks like. Okay, so that's looking right. It's its format is because we're aggregating by days, so let's aggregate it by like second. Let's see if that changes the format of it there. Okay, yeah, that's not quite by second, but whatever, that works. So what we'll do is we're gonna change the visual on this. We're gonna change it to a line chart. The x-axis, I don't want it to be that. I want the x-axis to be the parsed timestamp. Oh, it's saying it's already on there, so remove that. Okay, so now we've got an x-axis, and then let's just graph like the maximum of the bid price, say. We're just trying to prove that some data got in there. And this thing is aggregating by day again, so it's a very boring graph when you aggregate by day. We'll aggregate by minute, and still pretty boring there. And that's, I suppose, because that particular stock didn't change price during that period. But let's add a filter on the symbol, and it's loading the symbols. So let's not include all of them. Let's just look at like silver or something. Hopefully silver changed price. No, it did not. So over this period, changed price a little bit. So okay, it is actually changing price. It's just we need to not start at 0, because otherwise everything's kind of clumped together up here. So let's just allow it to show the deviation. So instead of starting at 0 down here on the y-axis, it starts at 22. So you can see that we're graphing data, and this is data that's coming directly from our S3 bucket into a graph. And I could format this and all that, but it's really not the purpose of this video. The purpose of making this graph is really just to show that the data is there and that we're able to access it. Okay, I'm back in the AWS console. We're going to do the other fire hose that sends the data into OpenSearch. We're back in our North California region because I do believe OpenSearch supports North California regions. So we took a brief detour there for the Quicksight graph to in a different region there for a moment, because Quicksight doesn't support all the regions. But now we're back in the region we've been in the whole time, other than the brief detour. So we're going to create a domain in OpenSearch, which is the same as creating a cluster. I'm just going to call it stock price domain, or stock prices domain. And we're going to go with the standard create instead of the easy, because I'm not quite sure what the easy would cover up. Let's do a dev test because we don't want to break the bank here. We're going to do one AZ because that's a surefire way to save more money when you're just playing around. We'll take the latest version there. As for the nodes, we definitely don't want the large. Well, suppose we do want the large, but I would rather have a general purpose because it's probably cheaper. And just like one node. Let me make sure that I didn't miss something here, because I don't want to pay more money than I have to. Yeah, okay, I think that's fine. All right, so we'll keep the EBS storage at 10. So I changed this to the number of nodes 1, again, because I'm trying to save money. And I changed this to 10 gigabytes instead of 100, again, because I'm trying to save money. Because we're just playing around here. Okay, we don't need to enable dedicated master nodes because that sounds expensive. Blah, blah, blah. We'll enable public access because I don't want to have to set up a VPC endpoint to connect to this thing. This is the purpose of this tutorial is not to become a networking expert or anything. So you might want to shut this down after we get done with it. In fact, you will want to shut this down after we get done with it. Okay, yeah, it's fine to support IPv6 and 4. Enable fine grain control, that's good. We'll create a master user just to make it easy to connect. Oh, okay. It's wanting a better password than I typed in. Alrighty. We don't need to do any fancy authentication. No, we don't We don't need a domain level access policy. We just want only fine-grained access control for right now. I haven't played around a whole lot with OpenSearch, but again, this really just to prove that we can send the data using Firehose into OpenSearch and graph it. Okay, we'll use the default encryption key for everything. I think we can take all the rest of these defaults with us. Let me make sure there's not anything hidden down here. Yeah. Okay, so we'll create this. This is the latest version of OpenSearch, one availability zone. The M6 large is the smallest, I think, that we'll be able to. And did it estimate my price at all? Okay, it hasn't estimated the amount I'll pay per month. Some of the services in AWS will give you estimates of how much you'll pay per month based on your current configuration, but I am not seeing that here, so we'll just roll with it and hope that this saved us money by just using a single node, not huge instances. I think large is the smallest you can choose, and just 10 gigabytes on the EBS storage. I don't want to save that. Okay, so that should be provisioning, and while that's provisioning, we can go over to Firehose, and I'm going to create another delivery stream. It's again going to be the same source, the same exact stream as the Firehose we made before. We're just adding another consumer. So this is a fan out, if you will, to multiple consumers. Now note that unless you use the enhanced fan out on a Kinesis data stream, these two consumers are going to steal from each other, both add up. The throughput through both of the fire hoses is going to sum up, and you might hit your limit of throughput because they'll add on top of each other. If you use enhanced consumer fan out, I think that's what it's called, enhanced consumer fan out on Kinesis data stream, it will give separate throughput limits to each consumer. So you can add a whole bunch of consumers and you won't hit your throughput limit because they're each using their own throughput limit. But the way we have it, we're not paying the extra money for the enhanced consumer fan out. So all of the consumers I add to this are going to be adding up to hit my throughput limit. And so if I add too many consumers, I'll eventually hit my limit. Okay, so the next, the destination for this one is OpenSearch. The last one we did was S3. This one's OpenSearch. So the Kinesis data stream is the same stream as we used before, and they'll eat from each other's throughput. We'll just call this KDS to OpenSearch Firehose stream. And I'll say stock prices in here. Stock prices Firehose stream. Okay, we're not going to do anything fancy with transforming the records. We need to pick a domain, so that's the domain that we just created, and it is not ready yet. So let's see what's going on. I might just have to pause the video for a moment again. Okay, our OpenSearch domain has provisioned now, so I can click browse here and it's selectable this time. And then we just need to pick an index. An index is sort of like a table in OpenSearch or Elasticsearch world. So it's just a collection of similarly structured objects, or objects that belong together. So stock prices is what we'll call our index. We can have multiple indexes within a domain. And then the only other thing that we need is somewhere to put backup data. So this is why I created that junk bucket earlier. So we'll use that. And so we're just creating the fire hose to send data from our Kinesis data stream into a specific index within a specific domain in OpenSearch. And again, both the fire hoses are connected to the same Kinesis data stream, and their throughput will add together and may end up hitting your limit. But in this example, they're nowhere near the limit, so don't worry about that. Okay, so now I'm gonna send more data into my fire hose. Oh, I'm already sending data into the Kinesis data stream right now, so this new fire hose should pick it up, in 60 seconds or so. Let's double check that our new fire hose has a 60-second buffer. So yeah, I guess I missed this part when I was configuring it. That's the retry, but the buffer hints, we gotta expand this, and let's decrease this to 60 seconds so that we don't have to wait a full 5 minutes for it to output data into OpenSearch. Okay, so now our buffer interval says 60 seconds there. This is a buffer interval for backing up, so that we don't care about as much. Okay, so we'll just wait for a moment, and once that data is available, we can pop back into OpenSearch, and I suppose we can do that now. So let's pop back into OpenSearch. We have one domain here, so let's click on that, and then it's got this link here that will take you to OpenSearch dashboards, which is basically Kibana. It's just kind of the UI for looking at your data that is stored in OpenSearch. Okay, so OpenSearch dashboards, sure, that's what we want to do. We want to add our data. So it says that there isn't any data at the moment, so we'll just have to wait here for a minute. Okay, there's still no data in our OpenSearch domain, so I went back and looked at the fire hose that's supposed to deliver it there, and I see some errors here, and it says no permissions. So what's happening here is, in our first fire hose, we said, okay, the source is Kinesis data streams and S3, and the AWS console automatically gave, when we created that fire hose, the permissions to access the source and the destination, KDS and S3. In this case, the permissions to access open source are not automatically granted by the console, so we've got to go in and do some kind of manual work ourselves to give it permissions. So what I'm going to do is I click on the configuration tab here, and this is the IAM role that this fire hose is using. This is the IAM role that AWS created for us, and we've got to do a little bit of work here. The first part that I'm going to do is easy. So on this role, I'm going to say, hey, attach a policy and give it OpenSearch full access, because it didn't do that before for us. The second part is pretty weird. So I'm going to copy the ARN here, and I'm going to go into OpenSearch dashboards, and I'm going to scroll down here, click security, and then roles, and then I'm going to click on this all access role right here, the link that takes you into the all access role, and then I'm going to click on mapped users, and I see that my user has permissions, but what I also want to do is manage the mapping and add the ARN of the fire hoses IAM role, and allow that to also be authorized to for all access to my OpenSearch. Okay, so this is pretty weird. It's not like a lot of the other things that occur in AWS. This will probably change eventually if I had to guess, but this is how it works right now. And so now I can go back here and, oh, well, now it's already asking me for an index pattern, so it must mean that it liked what I just did. So I think I called the index, yeah, stock prices. There it is. So I don't even need the wild card on that. We're just gonna create this index pattern. This just something you have to do in OpenSearch dashboards, and I'm not going to explain it any more than that. Okay, so our data is in here. So now we want to create, we want to create a dashboard from this. So we've already added our data. So let's get into dashboard, create a new dashboard. Let's create a new gauge here. We're going to use our stock prices. Okay, and so we see that the count of records that we have in there is already 34,000. Now if I refresh it, is it going to change? No. Okay, so what's going to happen is it's going to change every 60 seconds. So what I'm going to do is I'm going to wait about 60 seconds and then try this again. I'm going to pause the video just not to waste your time. Okay, so I waited a little bit longer than I meant to, but it updated, and it should probably say the same thing. Oh, another minute just rolled over. So every minute it's going to change, but if I do it right now, it won't change. It'll stay the same. So this is just a count of new records that are coming from the fire hose into OpenSearch, and they come once a minute in batches. Okay, so we were able to take one Kinesis data stream and send it to two different persistent stores, S3 and OpenSearch, using two different fire hose consumers, and make some simple graphs just to kind of prove that the data got where it was supposed to go. So we've accomplished our task here. Okay, we're done with this AWS pipeline. So thanks for watching, and I hope it helps you become an AWS guru. Check you later.